Hey guys, I'm going to tell you about reflection in just a second, but first I want to light me some incense. Pay no attention to the noise this lighter makes. Oh, yeah. Mmm. Yeah, that's pretty good. Oh. So reflection is a great thing. One incredibly common use of reflection that humans use in everyday lives is looking in mirrors and taking selfies. Oh, plenty of that. Yeah, let's take a selfie. Yeah. So, you may be wondering why I seem so very happy. Well, I would say a good explanation for that would be the fact that I am going full commando in gym attire right now, and especially my favorite shirt. So, that explains the grin. How do I... So now that my outfit is explained, I'm gonna run down and see if I can find any reflective items. So I looked up and down my house, and I was actually able to find like a lot of reflective items, but unfortunately there were only a few appropriate ones. So I will be using this little ball. It's kind of reflective. It's got a little bell in it. This little squarish mirror. This circular mirror, and one moment. And my guitar. So, first of all, I'm going to teach you guys about a little something called the law of reflection. Now, the law of reflection in words means that the angle of incidence is equal to the angle of reflection. Now, I'm going to draw that out for you because I had no idea what the angle of incidence was at first. So, imagine this straightish line is a mirror. Yeah, straightish. Okay. And first of all, we're going to have to draw the normal line, which is essentially just a line that's perpendicular to the mirror. So this is going to be our normal line. So, now here's our ray of light here coming in at first. So, it hits the mirror right here. So, the angle in between the normal line and the original ray of light is what we like to call the angle of incidence. See that? There we go. Now, the light will bounce off the mirror, just something like that. And essentially, the angle of incidence will be the same as this angle, which we call the angle of reflection. So, the angle of incidence is equal to the angle of reflection. Okay, everyone. So here we have just a regular old mirror, but here it is in the shape of a circle, but it's also a spherical mirror, because see how it makes everything blubbery? It's kind of magnifying, it seems, in a way. Like, when you look close at it, it makes me look fat. So, the thing about spherical mirrors, here, I'll show you a diagram really quick. And these lines right about here represent, like, parallel rays of light. So it'll take the parallel rays of light and focus them in on this one point right about there. And that is what we call the focus point. And this whole thing does relate to satellites, and I'm going to get to that in just a second. So, for now, we have the spherical mirror right here, and you can use this just like you can use a magnifying glass. You can use it to burn ants and all that. So, you can, like, focus rays of sun, just like the parallel lines I showed you. So, imagine for a second, it's a sunny day. You know, that's my sun right up there. So, clearly it's not actually sun, it's my light. So that's all we're going to use, but what I'm going to do is I'm going to move the mirror closer and closer to the wall, and the point is going to get slightly brighter and slightly more concentrated as we move closer and closer to the focus point. So as you can see, it's kind of distorted right now. It's not going to get a whole lot better, but it will be noticeable. So I'm getting closer and closer. See how it kind of focuses itself there? That's because it's closer to the focus point. Sorry to distract you guys, but look at that. Oh, that kitty is out cold. Oh my. Oh, I'm pissed I woke him up. Something I said earlier, this right here is the focus point. So, when you see like a satellite dish, like the ones for satellite TV, you'll see this little thing. It kind of reminds me of his foot. That's not important. Anyway, this thing is positioned pretty close to the focus point, so it can pick up the focus point. The focus point is where the satellite takes the rays and refocuses them again, because they're very dispersed and faint because the signal they're picking up is incredibly far away. And another something I want to make note of is that you cannot get a perfect focus with a spherical mirror, and that can be mathematically proven. To get a perfect focus, you will need a parabolic mirror, which is more in the shape of a parabola. So as you can see, focus there is far nicer than focus here. Alright, time to mess around with my laser pointer here. So, something I want you guys to remember is the law of reflections, that the angle I shine the laser pointer at this mirror, for example, will be the angle, same exact angle it will reflect off. So, there's my hand, there's the mirror, and there's where it's reflecting to, and kind of does a pretty cool thing, because it's like a layer of glass in between the actual mirror and, just bordering the actual mirror. So, something I kind of like to do is shoot the light sideways on the thing, and it does. It looks kind. I find that it looks cooler when you shine it on the corner. You get a lot of this stuff. That's just a cute little experiment of mine. So I showed you that spherical mirror of mine. A spherical mirror is one section of a sphere, but the inside of a sphere. So this, reflective other sphere I have, I want to shine this laser pointer, which is kind of like a very concentrated ray of light, and I will shine it on this, and what I think is going to happen, I think it's going to disperse this concentrated ray, which would be the exact opposite of what the spherical mirror does to light rays. It focuses them. So let's shine it on here, and it'll probably pop up on the ceiling. Oh yeah. Yeah, that's pretty cool. Yeah, this is what it's supposed to look like. And, ooh, I shined it in my eyes. This is what it looks like now. And I didn't show you guys my guitar for nothing. It's also kind of reflective. So, let's shine this baby on here. So, you can see it over here, but I wonder why you can see that little extra dot too. The brighter one is the original one, and that's the reflection of the original one. But I'm actually kind of curious on why I see that second one, but I'm totally not going to look it up or anything because it's late. Anyway, good night, guys.